this is obviously feeding into your supply chain in a major. So the key principle of lean operations is relatively straightforward to understand. It means moving towards the elimination of all waste in order to develop an operation that is faster, more dependable, higher quality products and services, and above all, operates at low cost. So they're the main criteria that you're trying to address when we're looking at lean operations. Now, we've all sorts of names or nicknames or synonyms for lean operations. For example, here we have continuous flow manufacturing, high value added manufacture, stockless production, low inventory production, fast throughput manufacturing, blah, blah, Toyota production systems. Probably my favorite version of it all is this Toyota production system. And it's kind of taken the number one position in when we talk about just nearly every time you talk about JIT and supply chain, lean supply chains, we almost always defer to um, these guys here, the what you call it, Toyota, Toyota guys. So the materials flow traditionally, this is how stuff happened. You had stage A, stuff was made, put into a buffer, into a warehouse, or this could be work in progress. It could be company A here, it could be manufacturing products and outputting it into their warehouse, which then eventually the company B and so on. So that could be a long process, or it could be even within an organization, within the production line. So the chassis are produced in one part of the organization. They're put into storage temporarily on the facility until they're ready to be painted, and then they're painted, and they're put into storage until they're ready to put the engines on them, and so on, so on, so on, so on. But the JIT approach works differently. We cut out the buffer inventory. So it's like a drumbeat. We try and sink ourselves. So the driver in this case is stage C. They're the ones that are delivering to the customer, so they know the beat at which they need to produce to service the various customer, or to service customer demand. So they set the beat on stage C. So that beat then is filtered back to B. So they pick up on the same rhythm of stage C, which in turn picks up on the rhythm of stage A. That's when we start to place the orders to keep going at the right cycle time. Hence, we reduce all this need for buffered inventory, a waste, money saved, increased profitability. Okay? And this is always one. At least it's coming out a little bit better here. But the reduced inventory levels. I'll have to play this. Oh, Jesus. Okay, here we go. So, what do we have here? How do we want to? We oftentimes we don't see all those additional costs that are happening down below the water. Now, I'm not sure how well you can see that. Sorry, I need to turn on the video for starters. I don't know how well this is coming out in your slides, but below the line, below the water line, you have work in progress, defective materials, scrap, downtime, rework, and all of that sort of stuff. All of these elements that are productivity problems, as they categorize them here, are issues which we don't see. And oftentimes these are disguised by having too much stock, because you don't see these latent inefficiencies or incumbent inefficiencies inside your organization, because the amount of stock of finished products ready to move on to the next phase, and so they're disguising it. Okay, and the wrong window. And this is what happens when we begin to reduce our stock levels, then all of this stuff becomes more visible. And this is what happens. Hopefully a little bit faster. Bang. we're beginning to see that now they've graded these in a particular order. So work in progress would be the first one you see. So buffer stocks and work in progress. If we start to eliminate these, why? Because when you have stuff in work in progress, when you have buffer stocks and so on, accidents happen, products get mislaid, things get stolen, and so on, and that can be critical to the next stage in the production process. So we start to look at these work in progress, and then of course defective products, as they call it here, or the defective materials. So we begin to see more efficiently and more effectively when we have less stock, when we're beginning to run out of stock, or when we have low stock levels or no stock levels, we can see purely what we're left with. And these products or the components have to be of such high quality that we don't need to be keeping stock of these. Therefore, we can produce far, far more efficiently without. So we begin to put pressure onto our suppliers, and in most cases, we push the onus of responsibility of quality directly onto the suppliers and say, if they don't meet these quality standards functionally, conformance to specifications, meeting requirements, and so on, then we penalize you, and we just drop you, and your contract becomes null and void, and we don't pay you, blah 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 blah. So the list goes on. So if we take the just in time and time and capacity utilization here, so fewer stoppages, so it leads to low inventory, so problems are exposed and solved. That feeds back up into focus on production when only needed, producing stuff that's only needed. Lower capacity utilization, which it does essentially, because you're not going to be, so, accountants and asset managers would say, okay, we have these machines, we have this building, they should be working 24 hours a day, and everything should be to maximize the usage of them. Not necessarily a good thing, because that leads to all of these wastages that we've just described, stock and so on. So having the right capacity at the right volume to be able to meet the demand is the key to it. So you end up with no surplus production, which goes into inventory. And when you're working on your internal systems to achieve these levels, then you need to be able to feed this back to your supplier, who in turn goes to their supplier and down the supply chain. Hence, when you have all of these mechanisms in place, now you might be sharing some of the ideas inside here. What have you done to improve, reduce your utilization capacity? What have you done to eliminate surplus production and so on? So you might be able to feed this information back. It could have been a new machine. It could have been some new equipment, some newer technology, production technology in your particular space. And therefore, is there how to say, a companion machine or a companion piece of equipment that our suppliers could use to produce at the same volumes and with the same quality? Is there another version of this new technology that our suppliers could potentially use, and so on? So these are all the kind of things that we need to be able to look at and adapt and share. That's a just approach. If you take the traditional approach, it's pretty self-explanatory. Focus on high capacity, producing more at every stage ends up with extra costs going into extra production going into inventory, and causing more and more stoppages at the various stages. So high inventory means less chance of problems being exposed and solved, as I mentioned, and more stoppages because of problems when you have high inventory and so on, all this sort of stuff. So I'm just trying to keep a little bit lubricated. How are we doing? We're not doing too bad. So just in time aims to meet demand instantly with perfect quality, no waste. More fully, improved overall productivity and eliminates waste. Cost-effective production and delivery of only the necessary quantity of parts at the right quality, at the right time and right place, while using a minimum amount of facilities, equipment, materials, and human resources. So just in time is dependent on the balance between suppliers' flexibility and users' flexibility. Hence the dynamics of 4.5. So and they use a picture there of chef or cook or whatever it is. You don't keep producing the same stuff. You have to be responding to each customer's choice on a menu. That's the message we're trying to get across to you there. So it accomplishes just-in-time is accomplished through the application of elements that require total employee involvement and teamwork. Okay, I feel generous for 10 marks, 10% straight across the board. Are you all paying attention? I can see some people moving forward already. For 10%. What model or system, and I need the precise 5 letters, maybe, describing a model or a process that covers the just-in-time and then particularly underpins the last element. What model? 10%, going for nothing.
Can you repeat, Mark?
Step off the screen.
What model?
I need to see. I tell you what, beg your pardon, I take no answer just yet. Put the answer into chat so I can trace the person.
Yeah, but can you repeat the question well?
I'm not getting anything yet. It's a specific process, very advanced process, methodology. I have to get the precise acronym, the letters of what it means. I'm turning myself off video for a moment. No, I'm not seeing it coming up yet. You need some music to help you think. I played this piece of a song out for a few minutes, a few seconds. Think hard. Am I getting anywhere? Okay, another hint. It's not plan, do, check, act.
Mark?
Can
you repeat the question again?
If you look at that last point on the slide deck in particular, it says JIT, or just in time, is accomplished through the application of elements that require total employee involvement and teamwork. And that's one of the criteria of a particular system or methodology. And that's Toyota isn't quite what I'm looking for. It's not the answer. It's another system or methodology that's more advanced than plan, do, check, act. And I'm looking for the 5-letter acronym that this system uses. In actual fact, the question is so difficult, I now decide I'm going to up the marks to 20%. 20% of marks to the first person that can give me precisely the acronym I'm looking for. The 5 letters that mean something. that are not Plan, Do, Check, Act, more advanced than that. It's built on Plan, Do, Check, Act.
Have a look in the chat.
No.
There is no correct answer. Any answer is correct?
Is what?
Is any answer correct?
Nope, nothing in there correct. Which is good because you can all see the answers, I assume. Yeah, you can because it's been posted to everyone. Come on, guys, you'll have to think about this one. I know we've mentioned it. Pretty sure we did anyway. You certainly would have come across this in second year operations. So did you not learn anything from me in second year?
No, that's not true at all. But we did a lot of stuff, you know.
I know. So business model canvas, no, not that, no. I'm looking for a particular advanced initiative or system or methodology that's used in companies to help them improve the way they're doing things. And it has 5 letters, acronym. 20% is going for this. What time have we got? We've got 4:30. I'm going into countdown mode. 5, 4, 3, 2, 1. Have you ever heard of DMAIC? DMAIC.
It's in the chat. It's in the chat. Fiona McHenry, DMAIC. DMAIC from Fiona McHenry. DMAIC, 4:29 p.m.
Your pardon. You're right, actually. Yes. Good girl, Fiona. Why did that not come up until now? Yeah. Okay. Sorry about that. That's it. Fair play. That's it. Fiona, just send me an email with your student number as well. But that's it. Define, make, apply, and improve, and control. Okay, it's part of the 6 Sigma approach. This is the methodology they use. It's that cycle that they go through. Small. It's used kind of by like with the Toyota system when they talk about Kaizen, continuous improvement. Okay, so that's essentially what we're describing here in this. But it involves total employee inclusion. You know, and that's the key to it: employee involvement and teamwork. But don't worry, as I said, I have been known to do this a number of times. It won't be the last 10 or 20% that I'll be giving away. Was it last year in this group or the year before last? Someone's yes, it was actually the 4th year students, and was one of the 3rd year students on supply chain last year. Went away with 90% on one of my questions.
Maybe last year.
Last year, I think it was last year. Yeah.
Last year.
It was last year. It was one student just got 90%, and I think she was a German student. Trying to remember. But the interesting thing about it, even though she didn't have to do any of the assignments, she came in and did all the assignments anyway with her team, particularly the teamwork. It was interesting. Anyway, I do have these tough questions that I come up with every so often. So anyway, if we look at this here, where am I now? And the last element that we included here, a key philosophy of just the time is simplification. And that's the important time. With all of these, you will have people talking about this stuff and they really don't understand what they're talking about. Why? Because they've overcomplicated. Just keep it simple. That's why I prefer personally to talk about plan, do, check, act, because it's simple. It's such a simple model. People go off and try to compound this and add other elements to it to make it look important or to put their own mark onto it. I have actually seen academics using it for students and saying, what was it? PDSA. I said, are you for real? They were talking about plan, do, study, act, or something like that, or plan, study, do, and act, or some stupid stuff like that. And they went off and wrote papers about this. And for crying out loud, seriously did need to get a life. Seriously need to get a life. Because the simple model that's already there is proven. Plan, do, check, act. Get out, and it's a simple model. As I've said so many times, don't look for complexity where it doesn't exist. The real fun is making making complexity simple. Okay, as I say, easier said than done in many cases. So I'll start going through and finalizing out what we need to cover here on this. So again, it's eliminate waste, involve everyone, continuous improvement. And so how do we achieve this? Sets the techniques for managing operations. So basic working practices, design for manufacture, and so on, down through workflow layouts, total productive maintenance, that TPM, that's part of the Toyota system. They've kind of borrowed that from there. Set up reduction time, so how long it takes to set up machines. So if you have small machines that are quicker and easier to set up, total people involvement, and some of the changes we put in there into total people involvement will be the machine operators. We train them on frontline maintenance, and that's also where this. TPM I knew there was a conflict there. TPM is also total preventative maintenance, which means that people are trained to. You don't need to always have to wait for the engineers to come in and fix machines, that people can fix basic faults and just-in-time supply. So all of this JIT as a method of planning control. So you have pull scheduling, Kanban, and I know people say, yeah, but Kanban was mentioned. No, I was looking for the complete Six Sigma approach that overshadows or overarches or umbrellas all of these initiatives: just-in-time, agile, lean, and so on. And then level scheduling. So here's the 5 S's, as they call them, or the as applied in the just-in-time approach. Sort, eliminate what's not needed and keep what is needed. Straighten, position things in such a way that they can be easily reached whenever they're needed. Shine, okay. Seri, Saiton, Saiso, Sauketsu, I beg your pardon, and Chitsuki. These are the 5 Japanese names. And then standardization, maintain cleanliness and order, perpetual neatness. And lastly, then we have development, commitment, and pride in people. Now, if you take, for example, position things in such a way that they can be easily reached whenever they're needed. It sounds like stating the obvious, but I know. If you were a kid like me when I was growing up and you went into your father's shed in particular, and you went anywhere near his equipment or tools out in his shed, he would always say, if you said, Dad, I want to borrow the hammer or I want to borrow a screwdriver, what would he say to you? He would probably say to you, there's a place for everything and everything in its place. Yeah. In other words, put it back exactly where you got it. Okay. And that's what this means. It's stuff that we would have learned as a child, being used in production and as a clear instruction. And you know yourself. Let me put it this way. Some of you you're all at home now at the moment. If you were in and out of college and you all sat down for breakfast in the morning and it was your turn to clean up the kitchen, and your colleagues came back home and saw it wasn't clean, they'd be pretty ticked off, wouldn't they? I would imagine so. The same principle applies. In other words, clean up after you. And some companies actually did an analysis of this, and with photocopiers and computing and machines and so on, and then reset it to default values That way people won't waste time, and so on, so on, so on. There's loads of examples. Ishikawa is one of the guys, one of the Japanese quality gurus and management consultants who, I couldn't think of the name of that this morning, actually. Ishikawa, that's the guy's name. He's the guy that came up with a lot of these simple little approaches, and we say, but it's so obvious, but yes, but everyone isn't doing it. Okay. And then volume stream mapping focuses on value adding activities. So it distinguishes between value adding and non-value adding activities. So and similar to process mapping, but different in 4 ways. It uses a broader range of information than most process maps. It usually it's usually at the higher level, 5 to 10 activities that most process maps. And then it often has a wider scope, frequently spanning the whole supply chain. So value stream mapping, in other words, what steps, what parts of this are of value? Do we need custom clearance agencies at between all the different supply, or can the one custom can the one single customs clearance agent cover all of the companies in the supply chain? Probably. It depends on the flow of materials. So that's the kind of thing we're looking at, getting value out of. So rather than hiring 3 or 4 or hiring one customs agent on the way in and another customer agents that's delivering your products, arranging your products, going into different geographic markets, get the one person to do it. Why they have specializations. That's why when we will come to it later on, we'll be looking at for 3-party and 4-party service logistics providers. Okay. And then what do we have here? Value stream mapping for, and this is just a simple example of it. If you're looking at an air conditioning company, and what we're talking about here is it's a simple example. So you have an order coming into the sales office. They carry out a survey. So you're installing an air conditioning system into a building. Okay, an order. The company wants to put in air conditioning, some other company. And they contact your sales office. Oh, okay, I'll use my mouse for this. They contact, where's my mouse gone? I need it. They contact the sales office. The sales office goes out and carries out a survey to see, well, what's the size of the building? What do they need? Blah, 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 blah. How big is it? And we'll come up with a quotation. And then they go and it waits in the branch before the order is confirmed. So it goes into operations and planning. Then we track the job. So we have to wait for the assembly. We assemble the bloody thing and we ship it to the customer, to the branch, and we wait there. It waits inside in the branch before it goes out into the frame or the construction or into the module unit itself. And then we have to wait for the installers to come along, and then we go and install it. So all of these, but you see what's happening here. You have wait here, stuff waits in the branch for the feedback for the survey too, so that you get an order. So when you make a sales office, the sales office send out people to do a survey, and then the customer has to come back and say, yeah, I'll place my order and all that. So the operations planning starts to track from the order through to the installation. And then you send out an invoice, and when the installation is complete the invoice, and then eventually get the cash coming back into your company. So look at all these things. You have 1, 2, 3, 4 identifiable high level wastage points because they're waiting. There's nothing happening. Can you improve on all of these areas? Probably. Most likely you can. Let me see. That's the and they're the values that are being put onto it. So if you have total time, average availability 100%, and then CT is your cycle time, or task time and cycle time. So you add all these up together, and if I get out of the way, I think here, cycle time equals 35 days, or could be 35 hours. In this case, it's 35 days, given it's a system. So now put these all into perspective. So you're looking at total throughput time from the time the customer contacted you to the time you've had it installed and paid for was 258 hours or 258 days, that depends. And then you have the waiting time. Look at all of this, the value added time, only where things were actually done, the installation, the frame, the assembly, the order, the survey themselves. Look at the times there. 30 minutes to process the order. 30 minutes, the survey, 30 minutes for the order, 5 hours to assemble all the components together, 60 minutes to put them into the frame, and then 60 minutes to install it. 8 hours. where actual productive work was done versus the 250 hours between all the pissing around and wasting time and making tea and coffee and playing music on the internet when you're supposed to be fucking lecturing them. So delivering smaller quantities, okay, and I'm going to fly through this because it's so obvious. This is why we talk about agility and dynamics and lean manufacturing and so on. Deliver in smaller quantities, and I mentioned that at the top of the conversation. So small inventory levels, and do it more frequently, and setting up the contracts to do so, and so on. And then waste is considering what kind of activities that you can have. This is just a flow chart of different waste: overproduction, waiting time, transport, process, inventory, motion, things happening, and so on. And then defective goods, as there another one, all influence the throughput efficiency of an organization. So these are just some of the ways. They're not all of them. It's just a fairly high level, because waiting times can be anywhere along the process as such, over times between productive processes. In other words, the non-value adding activities in the organization. These are waste. These are waiting times and are considered to be wastes. Yeah. So using the small machines, essentially you do things an awful lot faster. Just in time, small machines approach versus they're easy to move, easy layout, quick to set up, flexible scheduling options, cheaper tooling, planned maintenance, and easier to use. Emphasize on flexibility, economies of scale. Because if you have one machine that's bigger than the three of those, if that goes down and breaks, that's it. Your production stops. That's the only point they're trying to make here in this. It's not really complex at all. But the whole point about it is you can have flexibility. You can have two machines in action. You can have three different products going through those different machines, or three different variations of the same product going through at the same time, as opposed to having just one machine and all hell breaks loose when things go wrong. So the whole idea of just-in-time gradual reduction of inventory, identify exposed problems. Remember the ship on the below the waterline issues. Eliminate these problems and repeat the cycle. The emphasis on continuous improvement, or Kaizen, fundamental in Six Sigma and in the Toyota production system, or Toyota way of doing things. Any one of those names you can use, but continuous improvement. When you've done it, do it all over again. Find the next generation, the next process, the next iteration, the next product across the organization, and continue to do it. And this is just leveling production. There's no big deal about that. It just talks about how you can level out your productions on a bakery, for example, with different mixed products and so on. How do you get to optimize your machine usage? And an MRP, and we will have, as far as I remember, no, we don't have an exam, so this is off the paper. Just in time, feeding into simple routing, simple systems, so getting away from PERT, which is the programming exceptions, something technique, I can't remember. It's the precursor to project management. You have PERT and Gantt charts and so on, and then you're moving into materials requirement planning down to JIT and or MRP, and now we're moving on to JIT, pure JIT. JIT won't happen. That JIT can't happen in here unless you have the systems in place, and we're talking about ERP systems. And that's it, folks. That's all there is now. I was intent on finishing just before 5 o'clock anyway. So just in time finished, and control. And is there anything else I need to identify? Bear with me.
Can I ask a question, Marc?
Yes, indeed. Yeah.
Sometimes you can hear talking about just in sequence. Which is the difference between just in sequence and just in time?
Just in sequence. I'm not 100% familiar with just in sequence, but no, I'll check it out for you. I can't say that I've come across just in sequence, but I would imagine that it's a logical part of just in time. So doing the right sequence. Okay, in the sequence, if you have the right set of processes, and when you use process maps, defining the sequence of those process maps, you can actually improve efficiency inside an organization. So that underpins, or it supports a just-in-time approach. Does that make sense?
Yeah.
So you're using two techniques: value stream mapping and process engineering, or process value engineering. You're using those two type of approaches to identify where you can improve process, change them, put them in the right sequence, shorten them, lengthen them, whatever the case may be, and then if they're adding value. So we used to do it in a company where we did a complete process audit. And the first question was, do we have it? If yes, are we using it? If yes, can it be improved? If yes, we carried on. Then if we said, do we have it? Yes. Are we using it? No. Scrap it. Get rid of it. That was it. There was no further consideration. We literally, we were that surgical with our processes, and it made sense. No point. But in this case, Abbott said, no, if it's not suitable for all situations, then we need to take it out and rewrite. If it means rewriting 5 processes, so be it, as long as they cover what we do and how we can actually show we're improving our efficiencies. And this was in a company that was producing very advanced computer systems.
Okay.
Okie dokie, folks. I'll sign off now because I'm ready to jump in. I'll probably see most of you again anyway in the next 10 minutes. But so I just need to get my business modeling stuff ready to go online. Okay, I'll leave it with that. And for supply chain management, we'll see you next week, please God. All right, folks. Have a good weekend and enjoy.
Thank you.
Happy days.